Hello friends, here in this video we will see a problem on calculation of moment of inertia for unequal C section, that is channel section. For that, here is the question. Obtain the MI, that is moment of inertia, about the centroidal axis for a section as shown in figure. The diagram is given to us. Now for this section we have to obtain the MI, that is here I'll write down the data. Obtain the MI means we have to calculate moment of inertia about x-axis and moment of inertia about y-axis for the channel section which is shown in figure. Now to start with this, as we can see, this channel section is neither symmetric about x-axis nor it is about y-axis. So for that purpose, the first thing we should do is to calculate the centroid. That is, once we know the location of centroid, then only we can proceed further in the problem of moment of inertia. So the first thing is to calculate the centroid, and for that we require x bar and y bar values, and in that case here we need to divide this C section. So I'll divide it into three different areas. This will be rectangle 1. Here we have the second rectangle, and this one would be the third rectangle. Next, in the solution part, we can say that since the given unsymmetrical C section is not symmetric about any of the axis, that is neither x nor y. So here we'll say that therefore we need to locate the centroid, and for that the first thing is location of centroid with respect to y-axis is given by x bar is equal to a1 into x1 plus a2 into x2 plus a3 into x3 upon area 1 plus area 2 plus area 3. This I'll keep it as equation number first. Now therefore we need to know all the values. So area 1, it is clear that for the first rectangle width is 100, depth is 10, so area is 100 into 10. So area 1 will be 100 into 10, that is equal to 1000 mm square. Next, area second, since this total height is 80, from that if I subtract 10 and 10, that is 80 minus 20 will give me this remaining height for the second rectangle. So here we have area 2 is equal to 60 into 10, that is equal to 600 mm square. Here the distance is 10 mm. Now after getting area 2, we'll calculate area 3. It will be 60 into 10 again, which is 600 mm square. And after getting the values of area, next we have to know what are x values. So x1 will be the location of y-axis for the first rectangle, it will be at half of 100. So x1 is 100 by 2, that is 50 mm. x2 is half of 10, 5 mm. x3 is half of 60, that is 30 mm. So we need to put all values in equation 1. Put all values in equation number 1. So here I have x bar is equal to area 1 into x1, here is the value, area 2 into x2, area 3 into x3. So I'll put the values, 1000 into 50 plus 600 into 5 plus 600 into 30 divided by area 1 plus area 2 plus area 3. So therefore x bar, the value comes out to be 32.27 mm from left hand side. Now since the total width is 100 and now I am getting the value of x bar as 32.27 mm, so the distance of y-axis for this C section, it is 32.27 mm from left hand side. So from right hand side the distance would be x bar is equal to 100 minus 32.27, which gives me the answer as 67.73 mm, that is from right hand side. Now once we know the location of y-axis, we can easily locate it on the diagram, that from LHS it is at 32.27 mm distance. So here I am locating the y-axis. This is x bar, 32.27 mm. Next, from the other side, that is the right hand side, the value is 67.73 mm. So this is the y-axis for this unequal C section. Now similarly we have to find the x-axis, because on y-axis as we know there will be centroid, but at which point, for that we need x-axis, because that will give us the location of centroid. So similarly as we have calculated x bar, now we will calculate y bar. So therefore since location of centroid with respect to x-axis is given by y bar is equal to a1 y1 plus a2 y2 plus a3 y3 upon a1 plus a2 plus a3 keeping this as the second equation. So now for y bar we need to know y1, y2, y3 values. So I can say that looking into the figure, y1 is the distance of x-axis for the first rectangle. Here I have the x-axis of the first rectangle. So its distance with respect to the origin, that would be y1, and it is simple, it is half of 10, that is 5 mm. y1 is equal to 10 by 2, so it is 5 mm. Next, y2, that is the x-axis for second rectangle, and it will be passing through half of this So this is, since the total distance from here this is 60 mm, so at half of 60 there will be the x-axis, and it is starting after 10, so it is 10 plus half of 60, y2, 10 plus 60 by 2, and that gives me the answer as 40 mm. Then y3 is equal to, it is 10 plus 60, that is 70, plus half of 10, that is 75 mm. So here is the x-axis for the third rectangle. Now once we know all the values, we can put them in the second equation, that is, put all values in equation number second. So here we have y bar is equal to area 1, which is 1000, into y1, that is 5, plus area 2, that is 600, into y2, 40, plus area 3, which is again 600, into y3, which is 75, divided by area 1 plus area 2 plus area 3. So from this, the y bar answer which I have, it is 33.64 mm from bottom, or y bar is equal to, since the total height is 80, so 80 minus 33.64, that means it is 46.36 mm from top. So after getting this, we can locate it onto the figure, that it is 33.64 mm from bottom. So here is the x-axis located at 33.64 mm from bottom, and from the top the distance is 46.36 mm. Now once we know the y-axis and the x-axis, we can say that we have located the centroid, and here is the centroid G. Now as the centroid has been located, the next step would be to calculate Ixx and Iyy. So we'll first start with Ixx. So therefore, mi about centroidal x-axis is given by Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. Keeping this as the third equation. Now Ixx1, since mi for rectangle 1 about the x-axis of complete section, that is given as Ixx1 is equal to Ig1 plus area 1 into h1 square. This has come from parallel axis theorem. Now as we see, the x-axis of rectangle number 1, which is denoted as 1 1, and the x-axis for complete section, they are having some distance between them. That is why we have to use parallel axis theorem, and the distance is between the x-axis of section 1 and the complete C section, that distance is h1. So now I'll say that therefore Ix1 will be equal to Ig1 is BD cube by 12, because it is the horizontal axis about which we are calculating the moment of inertia, plus area 1 is B into D, and here H1 is, it can be seen here, 33.64. From that, if I subtract this distance, which is 5 mm, so I'll get H1. So 33.64 minus, for 5 I can write it as half of 10, that is, so that we can understand how it has come. Now B and D values, B is 100 and D is 10. So 100 into 10 cube divided by 12. Area is 100 into 10. Here we have 33.64 minus 10 by 2, that is 5 square. So Ix61, the answer is, it is 828.58 into 10 raised to 3 mm raised to 4. After getting Ix61, I can find out Ix62 in a similar manner, that is Mi for rectangle second about the x-axis for complete section. So here we are finding the Mi for rectangle number 2 about the x-axis of complete section, and for that purpose also we require parallel axis theorem. Ix62 is Ig2 plus area 2 into h2 square by parallel axis theorem. So now Ix62 is Ig2 plus area 2 into h2 square, and that I can explain it here in the diagram. That if we see the x-axis for second rectangle, it will be at a distance of, we can say here the distance would be 10, or in simple words I can say that it would be 40 mm from bottom. That is, here this is the x-axis for rectangle number 2. The location is 40 mm from bottom. So now if we see for this C section, the x-axis is at 33.64 mm, but for second rectangle the x-axis is at 40 mm from bottom. So again there is difference between these two axes, and that distance would be called as h2, and it is simple, it is 40 minus 33.64. So therefore Ix62 is, Ig2 is the horizontal axis and moment of inertia is BD cube by 12 plus area is B into D. H2, that will be 40 minus 33.64 square. So here I am going to put the values B and D. Now for the second rectangle, B is 10 and D is 60. 10 into 60 cube by 12 plus 10 into 60. This is 40 minus 33.64 whole square. So Ix62, this value comes out to be the answer which I have, in that it is 204.27 into 10 raised to 3 mm raised to 4. So this is Ixx2. Similarly, we can find out Ixx3. Ixx3 is equal to Ig3 plus area 3 into H3 square. By parallel axis theorem. So therefore Ixx3 will be, Ig3 is the moment of inertia about the horizontal axis, BD cube by 12. Area is B into D, H3. Now as it is clear from the diagram that for rectangle 3, its x-axis is located at distance 5 mm from top. This is 5 mm. But the x-axis for complete C section is located at 46.36 mm from top. So the difference between them, this is called as H3. So it is 46.36 minus 5. So 46.36 minus half of 10, which is 5. So therefore I'll go on putting the values. B and D for the third rectangle, B is 60, D is 10. After calculation, Ixx3 comes out to be 1.03 into 10 raised to 6 mm raised to 4. After getting all three values, we can put them in equation number 3rd. So therefore put Ixx1, Ixx2 and Ixx3 in equation 3. So therefore Ixx will be, Ixx1, it was this value 828.58 into 10 raised to 3 plus Ixx2 204.27 into 10 raised to 3 plus Ixx3 1.03 into 10 raised to 6. Now adding these three values gives me Ixx and my answer is, it is 2.062. I'll write it onto the next page. Therefore Ixx is equal to 2.062 into 10 raised to 6 mm raised to 4. So this is our first answer. Now after getting this first answer of Ixx, I'll write down similarly Mi for complete unequal C section about y-axis is given by Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. I'll keep this as equation number 4. Now first Iyy1, that is Mi for rectangle 1 about y-axis of centroid, Iyy1 will be Ig1 plus area 1 into H1 square by parallel axis theorem. Now in this, if we look into the diagram, then the y-axis for complete C section is at 32.27 mm from left hand side, whereas the y-axis for rectangle number 1 will be at half of 100, that is 50 mm. So there is a difference. So we are using parallel axis theorem, and that will be IG1 is the y-axis for rectangle number 1, and that is, for this B is 100 and D is 10, so it is dB cube by 12 plus area is B into D. Now H1 will be half of 100 minus 32.27 square. So putting the values, so now IYY, here as I have written, it is 10 into 100 cube by 12 plus 10 into 100, which is area, into 50 minus 32.27 whole square, which is h square. So therefore IYY1, the value comes out to be 1.147 into 10 raised to 6 mm raised to 4. Next, similarly IYY2, that will be IG2 plus area 2 into H2 square by parallel axis theorem. So now as we see in this diagram that the y-axis of second rectangle is located at 5 mm distance, that is half of 10, whereas the y-axis of the complete section is located at 32.27. So there is the difference between the two axes, which would be called as H2, and because of that we are using parallel axis theorem. So here IG2 will be the moment of inertia for the second rectangle about its own y-axis, so it will be dB cube by 12 plus area is B into D, and H2, that will be 32.27 minus 5 square. So therefore IYY2 will be, here D and B values for the second rectangle, D is 60 and B is 10. So IYY2 comes out to be 451.19 into 10 raised to 3 mm raised to 4. Next, after getting IYY2, similarly we can calculate IYY3 as well. So therefore IYY3 is equal to IG3 plus area 3 into H3 square, again by parallel axis theorem. So therefore IYY3 will be equal to, IG3 is the moment of inertia for third rectangle about its y-axis, that is dB cube by 12 plus area is B into D, and H3 is the difference. If we look at the third rectangle, its own y-axis will be located at distance of half of 60, that is 30 mm, but the y-axis for complete section is at 32.27 mm, so there is this difference which is called as H3. So H3 is 32.27 minus 30 square. So therefore IYY3 is, here D and B values, D is 10, B is 60. So IYY3 value will be 183.09 into 10 raised to 3 mm raised to 4. So after this we can put all these values in equation number 4. So therefore put IYY1 Iyy2 and Iyy3 in equation number 1, sorry, equation 4. So therefore Iyy will be Iyy1, it was 1.147 into 10 raised to 6, Iyy2 451.19 into 10 raised to 3 plus Iyy3 183.09 into 10 raised to 3. So after adding all the values, I get my final answer of Iyy, and it is 1.78 into 10 raised to 6 mm raised to 4. The second answer. So if we see in this problem, they were telling us to calculate two things. The problem was on calculation of MI for unequal C-section, where we have to obtain the MI about the centroidal axis, that is XX and YY. So for this unequal C-section, the MI about IXX, that is moment of inertia about x-axis, we have found out it was IXX is equal to 2.062 into 10 raised to 6 mm raised to 4. Similarly, Iyy, it was 1.78 into 10 raised to 6 mm raised to 4. Once we have found out both the problems, we have found out both the unknown values, we can say that the problem has been completed.